Welcome to part 2 of the PicoScope 2204A tutorial. In part 1 we set up a 1 kHz square wave using the signal generator and used it to compensate a ×10 probe. In part 2 we explore the signal generator further and use the arbitrary waveform generator, or AWG, to create a glitch and then set up a trigger condition to isolate it. The setup begins where part 1 ended, with a 1 kHz square wave displayed on channel A and the ×10 probe connected to the AWG using a BNC to crop clip cable. So let's open the generator menu and take a look at the various controls. If you find the menu covers part of the signal you're interested in, you can drag the menu to another part of the display, or even off the screen onto a second display to give you full visibility of the waveform. In this case I'm going to leave it in the center and actually move the waveform down 2 divisions by dragging the scale and allowing it to snap to the graticule. Next, select the drop-down menu to show the various wave types. Top of the list is Arbitrary, which we'll look at shortly. Then we have Sine, Square, Triangle, Ramp Up, Ramp Down, Sin X over X, which is an interesting wave shape. Here you'll see that the trigger point is not isolating the signal effectively, so all we need to do here, just move the trigger point up and then it always catches that main leading edge. There's also Gaussian, half sine, and DC voltage. Great, so let's go back to sine, and next we'll have a look at sweep mode. So just select sweep mode and what we have here is a start frequency of 1 kHz and a stop frequency of 2 kHz. So let's increase the stop frequency to 20 kHz. Kind of covers the audio range. And now I will move this to one side. And select the sweep. Can either be sweep up, sweep down, or, and in this case I wanted to do up down. And the sweep appears to be continuous, but it's actually increasing and decreasing in incremental steps, dwelling at each step for a set amount of time. This can clearly be seen by increasing the time interval and then the frequency interval. So if we increase the time interval to about half a second between each step and increase the frequency increment, we can see those steps quite clearly. Sweep generators are often used to characterize the frequency response of circuits such as filters or amplifiers, and being able to control the time and resolution of the sweep may be helpful. Okay, let's return those to the default setting. And close the sweep generator. Next we'll take a look at the arbitrary menu. A definition of the word arbitrary is based on random choice or personal whim rather than any reason or system. In the case of arbitrary waveform generators, it means not being limited to predefined waveforms but being able to create your own custom waveform. As a demonstration, I want to create a glitch amongst a set of regular pulses so that I can use it to show some of the advanced trigger features. So select the arbitrary button, and this opens up a new window which again can be moved around, and here you'll see quite a few menu items. So let's take a look at some of these individually. If we place the cursor over the menu item, we see the first one is import from a channel. Import data from a channel. This allows us to import a waveform from the oscilloscope into the generator. Import from CSV. This allows us to take a saved waveform and import it back into the generator. And in the opposite way, export as a CSV allows us to take an arbitrary waveform and save it as a CSV file. Here we have smooth drawing mode, we'll come on to that later, or line drawing mode, again, come back to that. Bitstream mode. So if I click into this, we'll see this gives us the capability to create a bit stream either with binary or hex, and I'm just going to write some random binary here. And we can see the hex equivalent is automatically calculated. We can set the logic levels. There. And if I go OK, we can see that set up in the generator. And if I now press OK, this exports it, and we can see that bitstream is now displayed in the oscilloscope. So if we return to the arbitrary menu, and we see this button, which is clear all, and apply, and this control shows the number of samples used to draw the waveform. And for the waveform I want to produce, we're going to need a few more samples. Let's put that up to the maximum, which is 4096. So the next step to creating the waveform that I want to create is to start with a standard waveform, which in this case I'm going to use this exponential wave. Then increase the number of cycles to 10 and zoom in using this icon on one pulse, and then select the drawing tool and draw in a glitch like so, which is a negative going glitch, and then press OK. And we can see that there is something occurring, but it's difficult to see as it's not being isolated by the trigger. And so to isolate it, I'm going to set up a pulse width trigger. But first I need to know what a normal pulse width is. So first I'm going to stop the trigger. And at the moment we can come out of the signal generator now. We're not going to adjust that any further. And I'm going to zoom in using the horizontal zoom control about 5 times. So here you can see this is the zoom overview showing the full acquisition, and in the box is what we can see on the display. We can move through that like so. And although we can see a glitch here, we're not going to concern ourselves with that. We're going to use this to show the triggering. So to measure the width of a single pulse, I'm going to drag rulers from this box in the bottom left hand corner. Let's put that ruler 1 there, and then ruler 2 here. And we can read the delta between the two cursors as being just over 50 microseconds. So that's all we need to know for the moment. So we can come out of the zoom, and now we need to set up our trigger, and we go into the advanced trigger menu, select pulse width. It's a negative going pulse, it could be a positive going pulse as well, and the condition we're looking at is less than 50 microseconds. We close that and we start the trigger, and at the moment it's still capturing all the pulses because these are just about 50 microseconds. But if we reduce that time now to 40 microseconds, it only isolates the glitch, as all the other pulses are more than 40 microseconds. And again, we can zoom in on this so we can see quite clearly what's happening. This is basically a threshold that if the pulse crosses the threshold in less than 40 microseconds, it triggers, and it ignores all the pulses that take more than 40 microseconds. So that concludes the second tutorial on the PicoScope 2204A, where we looked at the signal generator and width triggering. Thank you.